Now, in this lesson that is in our text 2.5, we're calling 2.4, that is the last section of Unit 2, and it's the time value of money. Now, a lot of this relates to what we did in the last section, and we will develop hopefully a nice list of formulas for you. So as we read this one, we want simple interest. Now, what is the simple interest formula? Well, it's interest equals the principal times the rate times the time. That's the simple interest formula. So, substituting, let's see what you get. So, 6350 is our principal. Our rate is 8% that we need to convert to a decimal fraction. And our time is for 1 year, so this is just 1. So put that in your calculator and see what you get. $508 is your interest that you earned if you put this money in at 8% for 1 year. Now 8% in these times is quite a bit. Our rates aren't that high right now. All right, let's go on. Now for number 2, you're going to put this in your notes. There's the simple interest formula. You substitute 2,500. Now the rate is 8.5%. Converting that to a decimal is 0.85. And it's for 3.5 years. So to make that easy, just make it 3.5. And let's see what you get. So that would be $743.75. So again, these are typical homework problems that we're using to do a little practice and review before you start, or if you started already, just for reinforcement. Now, as we look at example 3, they're asking us to do some comparison. Here's our values, our principal, our rate, and our time. And we want to do one using simple interest, which is this formula here, and then compounded annually, compound interest, which is one that we've done before. Now, you notice this is the formula we used in the previous section. In this section, they're changing it a little bit where they redefine some of this, but let's just stick with what we had. This will work out very well as well, and that's what we want to do. So, setting this up, by the way, the simple interest formula for future amount is this, but we factored out a P here. P from there and a P from there leaves us with this. So we're going to substitute 2,400 and then 1 plus the rate we said was 2% times 5 years. So in a moment you'll figure that, and then let's fill this one in. The principal is 2,400, and then it's 1 plus the rate, which is 0.02. Now our period of compounding is annually, so this is just going to be a 1. Our N is the period of compounding. and then it's n, which is 1 times the time, which is still 5 years. All right, take a moment, put those in your calculator and see what we get. So in our simple interest calculation, you get 2,640. But when it's in compound interest, you get a little bit more, $9.79 more. And that would be generally true. Now, my question to you, what's the difference between simple interest and compound interest? Different formulas, but what would be the background? Well, simple interest, your principal stays the same. In compound interest, each year, the principal is increased by the previous interest. So your principal is growing each year. That's the major difference. Now, part of any math course is, of course, reading the example carefully and then answering what they're asking as opposed to what you think they're asking. So here it says find the missing interest earned. So as you look through this little chart, they're saying there's the compound interest. Now they're giving you the future amount, A, and they're giving you the principal, P. Well, how do you find the interest? And hopefully you said you subtract the principal from the future amount, and that would be the interest. And that comes out to be, once you do that, go ahead, take some time, $302.61. Again, you have to be careful. What are they asking you to do? And that's what you put into the system. Now, for number 5, sort of reflects on what I've just stated, and hopefully you have an understanding. Take a few moments, read these over, and then let me know what you think is the best answer. Now, if you picked B, that is correct. Okay, but here it's sort of putting in words what we're describing and have been describing. So here is a particular case. What are they asking you to find? Well, find the present value of the following future amount. So in this case, we know the future amount, which is A, is going to be $1,000. Now, what we don't know is the principal. And to find what the principal is, we have to divide both sides by this. So I'm going to put this under the 1,000. Now it's going to be 1 plus, and we can think of all this being in a parenthesis. Now our rate is 7%, so 0.07. We are compounding it annually, so our n is 1, and it's over 25 years, which is 25 times 1. So let's make this nice and put the p then over here. Clean that up a little bit. And let's see what you do when you get your calculation. Now, you're going to have 1,000 divided, and then you have to put this in parentheses and see what you get for an answer. Now, I did this both ways. I had figured this out, put that answer in memory. Then I said 1,000 divided by this, answer in memory, got this. Or I put in 1,000 divided by, parenthesis, put this in, caret 25, enter, and I got this as well. So again, knowing how to use your calculator is an important skill here, as well as picking out the correct formula and answering the question they're asking. Now, for number 8, they're giving us some more background on a vehicle for saving money. There's a savings account, but then there's also certificates of deposit, which are called CDs. They generally have a higher rate because your money is tied up for that longer period. Okay, so here we're depositing 200,000. Wow. And how much will be in the account at the end of 3 years? Here they're saying the effective annual yield is this. So our time period is just going to be 1 here. So let's put that in there. 200,000 times 1 plus 0.037. And we don't need those other zeros actually for calculation. And this is going to be for 3 years. Now again, since our n is 1, we don't have to do any more than this. And in a sense, we could just add these ahead of time. So this is something that I would do normally. I'm just going to add that together. Since we're not dividing it by anything, this is just going to be 1. So you're going to put this caret 3 and then times it by 200,000. Let's see what you get. Okay, for the use of your money for 3 years, you will be earning over $23,000 if you have this kind of money. And of course, that's what all of these relate to, the time value of money. Once again, picking out the right formula, answering the question that they're asking. Now, for number 9, again, reflecting what we had in our flipped classroom lesson, using the rule of 70, which involves writing a 70, and then it says estimate the years to double if the annual inflation rate is 3%. So here we actually use the percent. We use the number 3. So 70 divided by 3 is going to be, and they want us to round to the nearest year. So when we do this, we get 23.3 that repeats. So the nearest year will be 23. All right, so this was like a shortcut rule that gives a pretty good estimate. It's called the rule of 70. Now, for this last one, we're using the future value where there's our base price, 2% inflation rate, and then it's 5 years later. So we're using compound interest, but this is going to be annually. So we don't need to put the n in there. That'll just confuse things for right now, since it's going to be 1. So to figure out this first one, I'll give you a hand. It's going to be 17,500. Now the inflation rate is 2%, so that's going to be 1.02. And I'm adding the 1 to the 2% over 1 doesn't change it, and it's going to be for 5 years. So that would go there. And then the next one would be 17,500. 1 point. Now for 25 years, still 2%, but our years in 2025, that's 15 years. And then you can do the same thing, but here it's 8% inflation. Let's see what you get. So this is what goes on in the real world. If you have a 2% inflation rate in 5 years, something that was 17,500 now is 19,321. We're rounding to the nearest dollar. And then in 15 years, if it was 17,500, now that same item would cost 23,555. Now, if the rate of inflation is 8% in 5 years, the 17,500 is 25,713. But check this out. In 15 years, that 17,500 is now 55,513. Again, rounding off to the nearest dollar. Okay, so you'll be doing some on your own. Remember, if you have questions, be sure you're asking. All right, we'll wind this up.